Hi, this is Nassim and it's homework number 1 for class CSC 577 recommender systems. So here we intend to extend the user recommender system. Um, so here we intend to use the significance weighting or discounted similarity instead of the default similarity measure in the recommender system implemented in LibRec. So the idea is in here is that we should be less dissimilarity should be less reliable when the two users have a really a small number of ratings in common. So it means that we set a threshold in here, and if the number of ratings in common is less than that threshold, we penalize this similarity and we say that the users are not that similar. Well, now for the implementation, so we put all our files in this package. We write the name of the package and write the name of the Java file in here. We need to set beta, so we define a variable in here and we set it to a number. Everything else is the same except that if you want to calculate the precision for the evaluation part, we have to set the ranking to true. Otherwise, if you want to calculate the errors like MSE, MAE, we need to set it to false. So now I haven't changed much of this file. Everything is the same except that I have described these two variables in here, which one of them is beta that I get from the configuration file along with the other parameters, and also the other user index, which I will describe in a second. So the rest of the functions are the same except the last function defined in here, create user similarity list. So in here, using this for loop, we can iterate through all of the users, and for each user we can get a similarity vector which tells us how similar is this user with the rest of the users. So after getting the similarity vector, we can also using these two lines of codes we can get the indices of the items that the user have rated. Why? Because we need to compare it with the items that the other users have rated, and to find the number of items, number of co-rated items, actually. So we compute the indices of the rated items in here, and using this while loop, we can iterate through the similarity vector, and each time we can find out what's the index of the user, and then using that we can get to the items that that user have rated. Then using the retain all function in here, we can find the intersection between these two to find the number of co-rated items. Getting the size, we can find how many items they've rated. So here we're updating our similarity measure. So we had the predefined similarity. Now we need to update it using the formula that I showed you earlier. So we calculated and we updated in here. Then okay. So in here it creates the user similarity list. Then it does the rest of the things. Now let's run the algorithm for a degree of overlap, when the degree of overlap is equal to 20, and let's calculate the precision for this. So it takes a while to compute the precision. Okay, now the job is finished and the precision is this number, which is higher than the default, if we've used the default UserKNN algorithm. Now let's calculate the MAE for our method. So the MAE and the ranking should be false. So this should be pretty fast. Okay, so this is the MAE value for our method. Thank you.